Last time we were looking at strange sorts of ways to compound things. We discovered that it is possible, extraordinarily possible, to end up with a situation by which we are compounding continuously. That led us to follow some mathematicians around in the French, and the French mathematicians came up with what I call the natural numbers, also called Euler's number. It's actually more normally called Euler's number. What is Euler's number? Well, oddly enough, it's easy to calculate because of the little tricks we learned trying to figure out what it was. We came up with several ways to calculate it, and you'll see an example of that on the paper right there. It is like pi. It is non-repeating, non-terminating. It can't repeat, can't terminate. That's been proven. Although, we can still play the game. Okay, we do all the rules we learned before. So, for example, e to the third times e to the fourth, well, that's just e to the 3 plus 4, which is e to the 7th. So we can treat it like any other number. Okay? We can estimate it if we know we're looking at e to the 6th. Easiest way to estimate that, again, is to put in your calculator, go second function ln. Second function ln. You go to the 6th power, you hit enter, and you get 403.4287935, roughly. Can that be the right answer? No, rather nearest thousandth, I should follow my own instructions. And that would be my answer. There's one other terminology we want to worry about, and that is, when is this thing causing growth or decay? The example is when you have bacteria in a normal situation, your petri dish, they start growing like crazy, so we call that growth. On the other hand, if I have a rock of uranium, it decays, which means we lose part of it. Now the difference is the rate here is positive, the rate here is negative. So in the compounding continuously formula, we look specifically at the powers. And I got 2e to the 3t. I look at that and go, well, the 3 is the rate. It's positive. Therefore, this is growing. Or it is exponential growth. On the next one, it's 6e to the negative 2t. That negative means my rate is negative. That would be what? That'd be exponential decay. Then last but not least, I have negative 6e to the 3x. You look at this and go, oh, wait a second, that's the rate. This is still exponential growth. I mean, it happens to be exponential growth in the negative direction, but it's still exponential growth. So theoretically, everything on the back you know how to do. Try it all out, and we'll check some of your answers later. Bye. Pausing.